It's Tanzu Tuesdays. Your host, Tiffany Jennigan.
There we are.
Hey.
We did it.
Woo! I'm so happy. This actually worked.
Is that the smoothest intro we've had in a long time? It feels like it is.
I think so.
All right, nice. But that's okay. We'll probably screw it up on the outro.
Yeah, it's gonna happen.
Bound to happen.
Well, welcome everyone again, or if you're new, welcome to Tanzu Tuesdays. And if you haven't been here before, we are on tanzu.tv/tt, and we have a new episode pretty much every single Tuesday at 1 p.m. Pacific time. So let's see. Let's talk about some of the upcoming things. So next Tuesday, so 23rd March, it's crazy. March is flying by real fast. Basically, we have Marcin, and I'm not going to try pronouncing his last name because I will fail. And he'll be doing a deep dive into tracing metrics and correlated logs. Tomorrow, we have code with Jaka Pilaman, and that is at 12 p.m. Pacific time. It's back to basics, dependency injection, and Spring IOC. So last week for TGIK, we had Josh Rosso, who went through the new gateway APIs in Contour, and we're still waiting to hear who is up for this week. But basically that is run elsewhere, and then we have it back up on, like, we also have it on Twitch, but it's on YouTube too. That's every Friday at 1 p.m. Pacific time. Then we have Between Chair and Keyboard. So on March 22nd, Nate's going to be chatting with Craig Walls, and he was actually on Tanzu Tuesday a few weeks ago, if you cut that one. Or if not, these are all up on YouTube. If you go to tanzu.tv again/tt, you'll be able to see all of the things that we've done so far. And then we have Tanzu Talk. So Kote has basically been experimenting with some like fun short form videos, and that's on tanzu.tv/talk. And you can kind of like see some of the things, some thought leadership, like through the lens of like TikTok dances, for instance. Like Paul really liked his short talking about money, the enterprise taboo. And we just had Spring One tour last week. The video for the first day, which was about 2 hours long, should be up on YouTube sometime this week. And then I'm also seeing about the video that I did for Intro to Kubernetes on the second day. The workshops, though, they weren't recorded, but you can find the workshops on, also if you go to tanzu.tv, if you go to the other part of the developer portal or the developer center, that you can see like workshops and guides and stuff, and it will be in there. Did I miss anything, Paul?
No, I think you got it all. I don't think we have any real upcoming conferences or anything right now. I'm sure there's stuff happening, but I was too lazy to go and hunt some down. I'm certainly not speaking at any in the next month or so. So I think we can pretty much kick things off and introduce Ria. Ria, how's it going?
Going well. Thanks for having me.
Thanks for being here. Why don't you tell us a little bit about yourself?
Sure. I am a maintainer on the Spring Security team. I've been on that team for about 2 years now. Maintainer, committer, there are various words that we use, but basically I do all things related to Spring Security, adding features, fixing bugs, answering questions, all of that stuff, all within Spring Security.
Nice.
That sounds super awesome.
It is. It's a great team. It's a great job to have. I'm very fortunate.
I'm definitely curious to hear some like more of like what Spring Security entirely entails.
Well, when we talk about Spring Security, there is the main Spring Security project, and there are also some other sub-projects that are under Spring Security. like the legacy Spring Security OAuth project, Spring Session, the new Spring authorization server that's experimental, and a few other projects that are under the Spring Security team. And in terms of Spring Security proper, that entails authentication, authorization for your application. You can use it to secure your application using OAuth, form login, LDAP, SAML, various ways to secure your application. And it also includes protection against various exploits like cross-site request forgery and stuff like that. Anything that has to do with security for your application, you can find something related in Spring Security.
So I would imagine you often see that paired up with the Spring Cloud Gateway, right? To sort of provide authentication across kind of your entire suite of microservices or whatever.
Yeah, that is a common use case, especially since Spring Cloud Gateway became, well, I guess it came out a few years ago and people have really started using it in the last year or so. So if you're on Stack Overflow, like we often are looking at Spring Security questions, a lot of them do have to do with the Spring Cloud Gateway.
Very cool. And then you're based out of Berlin, right? Oh, I answered the question and you asked it. That worked well, Tiffany.
Yeah, I'll answer it too. I am in Berlin in Germany.
Oh, I miss Berlin. I want to just be able to teleport.
Did you used to live in Berlin?
No, but my best friend, Jerome Petazzoni, lives in Berlin, and I've been there a few times for conferences and such.
Oh, nice.
That, and I just like Europe a lot and kind of wish I could be hanging out there right now.
Right. So what's your favorite local food in Berlin? Is it currywurst or doner, or is it something a little bit different?
No, Berlin is actually known as the vegan capital of the world. So it's really interesting that you can find all these vegan restaurants. In other countries, you might have a vegan restaurant and the type of cuisine is vegan, but in Berlin, you have vegan Italian restaurants, vegan Vietnamese restaurants, vegan Thai restaurants, vegan currywurst restaurants. And that's something that's really interesting.
That.
Huh,
yeah.
That's cool. Yeah, I'd never thought of that before, but I guess often like vegan is its own weird cuisine on its own. So it's cool that they're so into it that you can actually get like, we're going out for Italian and it just happens to be, you know, vegan Italian food. I like it.
Yeah. And in terms of my favorite, it's probably Vietnamese food. Berlin does Vietnamese food very well.
Oh yeah. Nice. So like a good pho soup or a banh mi sandwich. Now I want a banh mi sandwich. Damn it. I'm going to be thinking about that all afternoon.
Clearly, you should order yourself one.
I should.
Have you always been in Berlin?
No, I'm from Greece, so I grew up there, and then I lived in Canada for a while, around 9-10 years, and then I've only been in Berlin for about 1.5 years.
Cool. Yeah, I've been in the US and the US and the US.
It is a nice thing about having a European passport. There are so many countries that you can easily just go and live in, and you know, you have the right to live there and work there, and you don't have to worry about visas and all that kind of stuff.
You know, I used to say that,
so different
but
from each other.
My European passport was a British passport, and it's not quite as useful as it once was. Although I haven't really had the chance to travel on it since you know, COVID and everything happened, and travel was all cancelled for a year and now even longer.
Yeah.
So I actually don't even know what the status of the passport is and how easy it is to get to other European countries on it now.
Yeah, I'm not very familiar with it, but I do know some people have been having trouble with it. It's definitely not as easy as it was a year ago.
Right. Cool.
Also,
are we missing anything,
Maria,
Tiffany?
Sweet Killer 9, our regular likes your background. It feels like being in an office.
It is actually. It's the Pivotal Atlanta office. I don't know if they're still in the same office or if they've moved, but this is what it did used to look like.
Oh, I didn't even realize that was a virtual background. I assumed you were actually in an office
No,
And
I mean,
I was quietly judging you for being inside an office, but
no,
I
it's a
guess I
fake
can stop
office.
doing that.
Yeah. Yeah, please stop that. No, it's definitely a fake office. It's a picture of a real office, but I am in my house.
It's like one of the few from an office that I've seen that like the angle and everything could be real. Like a lot of them are just like, you can tell it's obviously like a virtual background based on the fact that they would definitely not be sitting in that part of the office.
Yeah, the goal is to trick people.
Well, you had me tricked, so
You did
it
well.
worked.
So like when you're able to safely like travel again, do you know where you would want to just like, if you could just go anywhere, where do you think you would want to go?
I was hoping to get to France last year over Christmas time. There is one city called Strasbourg. Okay, I don't know why that slipped my mind. And they are big on Christmas, and it's a very cute little city town, and everything gets very Christmassy around Christmas. And it's relatively close to Berlin, so I would easily be able to take the train to go there.
Yeah.
But maybe next Christmas.
I really want to see Munich during Christmas, like see their like Christmas market and everything.
I've never been.
I caught the
Munich or the Christmas market.
Oh,
I caught the train once from, I think it was Frankfurt to Paris, and that was quite a nice trip.
mm-hmm.
Yeah,
Yeah,
I like train trips in Europe, but they're still, still quite comfortable and enjoyable.
Yeah, I was going to say it's nice how well connected Europe is with the train system. I was expecting the US to be better connected with a train system, but it's really not. It seems like it's either flying or driving.
Yeah.
And I mean, there are buses, but it doesn't seem like people regularly use them.
No. Yeah, I've also done, you're in Berlin, I've also done Prague to Berlin, and that was a really nice train trip.
Mm-hmm. Yeah, that's another one that is pretty typical, and I was hoping to do at some point, but gonna have to wait.
Yep.
I'm having so much like your nostalgia now. What have we done? All right, cool. Do you have anything else, Paul, before we kick
No,
it off?
let's turn it over to Ria and kick things off.
All on you now.
All right, thanks. Sounds good. So I'll go ahead and share my screen. And let's start off today's talk. The title of the talk is Turning Kotlin Applications into Secure Native Executables. So we're going to be talking about Kotlin, we're going to be talking about Spring Security, and we're also going to be talking about Spring Native. This is meant to be a beginner-friendly talk, so if you are new to Kotlin, if you haven't used Spring Security before, or if you don't know what Spring Native is, you should still be able to follow along. The agenda for today, I briefly want to talk about the Kotlin support in Spring Security, and then we will get into the demo application. Most of this talk is going to be based around this demo application. We're going to start off with a Kotlin application that doesn't have security included. We're going to add Spring Security to it. We'll talk about the Spring Security filters. Then we'll turn that application into a native image and talk about Spring Native. And we'll finish off with an OAuth 2 example. So starting off with the Spring Security Kotlin support. In Spring Security version 5.3, which came out over a year ago now, we added the Spring Security Kotlin DSL. DSL stands for Domain Specific Language, and in this context, it's how you communicate with Spring Security in order to tell it how to secure your application. And so when we talk about the Spring Security Kotlin DSL, we're talking about how you can write idiomatic Kotlin code in order to configure Spring Security in your application. So if I click here, I'll take you to the reference documentation, and we can see some examples of that DSL. We have various examples of how to do things in the Spring Security reference documentation, and most of them are in Java and Kotlin, and some in XML as well. So if you're a Kotlin developer and you're trying to figure out, for example, how to enable the OAuth 2 resource server and configure JWT, you can look at the code here and see how to do it. If you're more of a Java developer and you're just starting to learn Kotlin, you might still be able to find this useful, and you can toggle between the tabs. If you already know how to do this in Java, you can see what the equivalent configuration looks like in Kotlin. And if you scroll throughout, you'll see that most of our applications have both of these options. Coming back here, let's move on to the demo application. So I created this demo application using the Spring initializer. I selected that it's going to be a Gradle project. I selected Kotlin as the language. I gave it a name, Kotlin Native Security. And for now, I'm just adding the Spring Web dependency. I could add some of the dependencies that we're going to need later, but I decided to start off with a very basic app, and then we'll add additional dependencies as we need them. So coming to IntelliJ, this is where my Kotlin application is. So if I open up this application class, the only thing that I've added for now is a REST controller. And if you're a Java user that's seeing Kotlin for the first time, this probably doesn't look that different to you. We'll go through what this is doing. So we've created two get mappings. One is the mapping for hello, and this returns a string, and the string is hello, happy Tuesday. We also have a talk info endpoint, which returns the body turning Kotlin applications into secure native executables on March 16th, 2021. So it's just some information about the talk day. I'm going to run this application, and we can try out calling these endpoints. The tool that I'm going to use to make the requests to these endpoints is just the HTTP command line. It's very similar to curl, but I personally find it a little bit more readable. So if we come here, let's start off with making a request to the hello endpoint. And we can see here, we get back an HTTP 200 status and the body that we talked about earlier. Similarly, if I make a request to the talk info endpoint, I get back an HTTP 200 and the information about the talk. As you can tell, this application has no security at the moment. So let's move on to adding security to it. To do that, we need to add the Spring Security dependency to our build.gradle. And to find that dependency, you might remember it, or you might just get it from the reference documentation or somewhere else, but I'm going to use the Spring initializer again. So I'll come here and I'll select the Spring Security dependency, and then I'll come to the Explore tab. Maybe some of you are very familiar with the Explore tab, and if you're not, you might find it very useful. So you can come here before you generate your project, and you can see what the project would look like before you decide to download it. And here I can see the dependencies that the Spring initializer would have added if I selected security. And I can see that this is the Spring Security dependency that I want to use. So I'll come here and I'll just paste that over, refresh my Gradle, and then I'll restart the application. As soon as you add this Spring Security dependency, Spring Security will come with a default configuration. Let me just start the application. The default configuration will secure all of your endpoints. So in this case, both of our endpoints will require a user to be authenticated in order to access the endpoints. By default, you can authenticate using form login or HTTP basic. Since we are using a command line tool and not a browser, we'll just use HTTP basic here. So as I was saying, all of the endpoints will be secured by default. So if we try to make a request to one of them, for example, the hello endpoint, we'll see that it now responds with a 401 status, and it tells us that we're unauthorized. It also has these additional headers, which it didn't have before, as you can see up here. And these are all security headers that Spring Security has added to help keep your application secure. For example, there's the cache control header, the X-frame options. I'm not going to go into what all of them are doing today, but the Spring Security reference documentation that we talked about earlier has information about all of these if you do want to learn some more. So this endpoint is secured. We'll try our other endpoint as well. And that also gives us a 401. In order to access these endpoints, we need to provide a username and password. And Spring Security will generate these default credentials for us. It'll generate a user with the username user and a random password that it'll print out in the logs here. So this is the password. If we restart the application again, the password will change. Because this isn't very convenient, and we probably don't want the password changing every time we restart our application, we'll go and create some custom users. The way we can do that in Spring Security is by creating a user detail service bean. So that's what we're going to do. Let's first say that we want to enable web security. And then we can create our security configuration class. In here now, we can define our user detail service bean. We can call it users, and it'll return a user detail service. For this demo, we can just store our users in memory. We don't have to worry about any kind of fancy data store. So we can return an in-memory user details manager. And then in here, I just have a little shortcut to create a user. And the user that I'm creating has the username user, it has the roles user, and the password here is actually just a password. I generated this password using the Spring Boot command line tool. You can Google it and see how to download it if you want to use it. But I've used it to encode my password using bcrypt. And you can see here that it has the prefix bcrypt. This is telling the Spring Security default password encoder that this password is encoded using bcrypt, and the default password encoder now knows which algorithm it needs to use to validate this password. And the reason why I've done this is because we shouldn't have plain text passwords in our source code, although this is a demo, so maybe you could say it wasn't that necessary. So now that we have our user, I will restart the application and we'll make some more requests to our endpoints, this time providing some credentials. Coming here, our talk info endpoint. If I make a request to it, I'm still getting a 401 because I didn't provide any credentials. But if I provide the credentials for the user that we just created, I'm now getting a 200 HTTP status and the body that I expected. Still these security headers that I was talking about earlier. So how is Spring Security doing this? How is it validating our credentials and how is it adding all of these headers? To do that, let's come and look at a diagram. And the way Spring Security does that is using filters. If we look at this diagram, it shows what happens when a request comes into our application. So the request is going to start up here at the client. In this case, the client is just our command line. It'll go through a series of filters, and then it'll arrive at the servlet, which is actually rendering our application. So the REST controller that we created is all the way down here, and these filters are getting called before the request reaches our REST controller. Now, one of these filters is a special filter that Spring Security has called the filter chain proxy. What this filter does is it delegates to some more filters that are security specific. And here we can see various security filters, and each of these has a specific role. For example, one of them is the header, the header writer filter that writes those headers that we saw. And some other filters will protect against cross-site request forgery attacks, will validate your credentials that you're passing in, and various other important security features. The filters that your application has are defined based on the security filter chain here. When you add the Spring Security dependency, the default security filter chain is being created, and that has some default filters as we saw, the header writer filter, it has the cross-site request forgery filter, some filters that will allow you to authenticate using form login or HTTP basic, and various other things. The defaults are there to keep your application secure, but of course you can configure them to suit the needs of your application. So that's what we're going to do next. The most typical way to configure the security filters is by extending a web security configure adapter. And this class has a method called configure, where you can configure HTTP security. So what I'm going to do is I'm going to override that configure method. And here I have the HTTP security object. Now, if you are a Java user and you've used Spring Security before, you may have done something like this, http.authorize_request, maybe saying any request needs to be authenticated. But the Kotlin DSL looks a little bit different. So in the Kotlin DSL, we can directly invoke this HTTP object like this. And sometimes the IDE gets a little bit confused about what I'm trying to do here. So I can manually import invoke, and that'll find the right input up here and figure out what I'm trying to do. For users that aren't familiar with Kotlin, this here and this here are equivalent. So I'll just get rid of that invoke method now that it's been imported, and I can specify my security configuration here. In this case, I will say that the application should be secured using HTTP basic. I'll keep the default HTTP basic configuration that Spring Security provides. If I wanted to add some customizations, they could go in here. I'm not going to add form login since we'll be doing everything from the command line here, and I'm not worried about logging in from a browser. And then I'm going to change the way that the requests are being authorized. So I'm going to create this authorize requests block. And in here, I'm going to create an authorization rule saying that if you access any endpoint that starts with talk, for example, talk info, then you need to be authenticated. However, if you access any other endpoint, then you are permitted to access it. So what I'm saying is just that this talk info endpoint, you need to pass credentials into in order to be able to view the response. Meanwhile, the hello endpoint is going to be open to everyone. So let's try this out. I'm restarting the application. We'll come here to our terminal, and this time we'll call the hello endpoint without any credentials. And we can see that we get back a 200 OK. Meanwhile, if we call our talk info endpoint without any credentials, we're getting a 401. So that's doing what we asked for. One thing that I want to point out that I've seen confuses people often is the difference between specifying an authorization role here that corresponds to a certain pattern versus specifying a security matcher up here. What the security matcher is doing is it's saying a request will only come into this security filter chain that I'm creating if it matches this pattern here. So if it starts with talk, then I can say any request needs to be authenticated since only the talk requests are coming in here. And our hello request won't even come into this security filter chain. So let's see how this differs from what we had before, because it is quite different. If I come here, the main difference is in this request to the hello endpoint. You can see here that the headers that I get back are not the same as the ones that I got back previously when I had the authorization rule configuration for the talk endpoint. And that's exactly because the request to hello is not going through the security filter chain. And to come back to the diagram that we were looking at, this is what the request path will look like if you specify a security matcher. So let's say we're making a request to the hello endpoint. It'll come here from our client. It'll come to the filter chain proxy, but because the request doesn't start with talk, it won't even go through this security filter chain. So the request isn't going to come here, and it's going to continue down this filter chain. And that means we're not going to get things like cross-site request forgery protection. We're not going to get the header writer filter invoked that's writing those headers that we saw. And that's different than what we were seeing earlier. So the previous configuration that we had, where we had this authorization rule saying that endpoints that begin with talk need to be authenticated. If a request came in to the hello endpoint, it would come here, come to the filter chain proxy, go into the security filter chain, because by default, any request will go into the security filter chain, go through the various security filters until it reaches this specific filter security interceptor. This interceptor will call the access decision manager. And at this point, it'll see that the endpoint doesn't match talk, and it'll grant access to the user, since anybody is allowed to access the hello endpoint. So both of these configurations have their use cases, but it's important to know the differences. In this case, I'm going to go back to our previous configuration, since I want all of our requests going through the security filter chain. I'm going to modify this slightly. I'm going to create an equivalent configuration here, and I'm just going to change it so that the hello endpoint is permitted to everyone. Meanwhile, the rest of the requests require the user to be authenticated. And because we only have 2 endpoints, these configurations are equivalent. However, this is a better default to have, because now if I add a 3rd endpoint, it'll be authenticated, versus if I were to add a 3rd endpoint and anybody would be permitted to access it. I would rather be on the safe side and make sure that we're requiring users to be authenticated before accessing new endpoints. And of course, if anyone is permitted to access it, you just create another authorization rule. So let's remove that. And now we have a functional Kotlin application. If you're a regular Kotlin user though, and you look at this, it looks a lot more like Java code than it does like Kotlin code. So let's make this look a little bit more like Kotlin code by using some of the other DSLs that Spring provides. The first thing we're going to do is come up here and add some initializers. Specifically, we're going to initialize some beans. We already know we have one bean, the user detail service. So let's come and move this bean from this annotated bean method to the bean definition DSL up here. All right, we can now get rid of this. The next thing that we're going to work on moving up here, oh, I forgot one thing. This is a bean. There we go. The next thing we're going to turn into a bean is our controller. So I can turn this into a bean by saying that I'm going to create a router. And in this router, I can specify my endpoints. So here, I'll create a get matcher for the hello request. And I'll say that this endpoint is going to return OK, and it's going to return the body that we have specified here. I can do a similar thing for the talk info endpoint. I'll do it a little bit differently. I'll start with talk and nest the endpoint under it. This way I can easily add some more endpoints that start with talk other than just the info endpoint. So here I can say get info, and this will return an OK with the body down here. All right, that is now equivalent to this, so we can get rid of our REST controller. And the last thing that we're left with is our security configuration. When I started writing the security configuration, I was extending the web security configure adapter because that's what most people are familiar with, and that's the way you've had to do it for a long time. However, as of Spring Security 5.4, which came out last year, you no longer need to extend the web security configure adapter to create your security filter chain. And instead, you can just expose a security filter chain bean. So I could get rid of this here. And then I can create a bean that returns a security filter chain. I'm injecting the HTTP security here, and I've just called this custom security filter chain. And then in here, I'll move this configuration. And then I just need to return http.build, which actually returns a security filter chain. So we can get rid of this now. And that's the equivalent configuration to what we had before. This isn't specific to Kotlin applications. You can do this in Java applications as well. But now that we have this bean, we can move it up to our Kotlin bean DSL up here. So we can say we need one more bean. First, we need a reference to HTTP security. So we'll get that. And once we have it, we can move this up here. And we don't need the return statement. Now we've gotten rid of our security configuration. And now we have our fully functioning secured Kotlin application, all defined within this bean definition DSL using idiomatic Kotlin code. And this looks a lot more like a Kotlin application than it did before. If the way we had it before is more readable to you, you can keep it like that. There's nothing wrong with it. But this does look a bit more like Kotlin code if you are very familiar with Kotlin. So now that we've added this functionality, let's move on to the next step, which is turning this application into a native image. In order to do that, we need to add some native image dependencies. And the dependencies that we're going to use are going to come from Spring Native. Now, there's a lot to talk about with Spring Native. You could do an entire talk all about Spring Native. And in fact, there is a Tanzu Tuesday in January where Sebastian talked all about Spring Native. So if you are interested in learning more and diving deeper into Spring Native, I would highly recommend you check out that talk. There is also an announcement that came out last week announcing that Spring Native is in beta. There's a blog post that has that announcement. There is a video that talks about the Spring Native support. And of course, there's reference documentation that shows you how to get started with Spring Native. So those are all great resources if you want to learn more about Spring Native, what it does, how it does it, and all of that stuff. We're really just going to scratch the surface of what you can do with Spring Native today. And in order to do that, we need to cover a couple of things. The first one is, what is Spring Native? And the second one is, why do I want to use it? So Spring Native provides support for compiling Spring applications to native executables using the Graal VM native image compiler. And why are these native executables useful? Because they have some key advantages, such as instant startup, instant peak performance, and reduced memory consumption. Now, of course, there are some drawbacks to this, one of which is a slower build time. And we'll see that a little bit later when we do build our application into a native image. But these sound great. So let's turn our secure Kotlin application into a native image. And to do that, I'm going to go back to the Spring initializer. And I'm going to add the Spring Native dependency. And yes, the Spring initializer does have support for Spring Native, even though it is still experimental, as you can see here. Once I add that dependency, I can come to the Explore tab here, and I can see what's different and what I need to add to my application. So the first thing I need to do is add this import. And then I need to add this plugin. This is the AOT plugin, which stands for ahead of time. And this performs some ahead of time processing to turn your application into a native image that is as efficient as possible and has a small a footprint as possible. So this is definitely going to be useful. We also need to add this Maven repository. And finally, we need to add a task, which is what will create our native image. Now, there is one more thing that we need to add, and it's a plugin repository. If I did forget to add this, it would give me a nice error message telling me that it can't find the plugin, and then I would remember to add it. But since I've added it now, it won't have to give us that error. All right, so that's everything we needed. I don't need to change anything in my source code or my business logic. I just need to change the dependencies that I'm using in my application. So once I have these dependencies, how do I actually get the native image? I'm going to come back to the Spring Initializer to help me with that. And you might already know the Spring Initializer will generate a help file for you that has some useful information such as reference documentation and guides based on the dependencies that you've chosen to include in your application. If you include the Spring Native dependency, it also has some useful information about Spring Native, such as how you create an image. So we'll grab this from here. I'll just zoom in a little bit if you can't see. And then we can run this, which will generate an image for us. As I said earlier, the build time is a little bit slower. So while this is running, we can come back over here and read a little bit more about Spring Native. So already here, it has some information about Spring Native, and it says this project has been configured to let you generate a lightweight container running a native executable. Docker should be installed and configured on your machine prior to creating the image. I do have Docker on my machine. And if we come to the reference documentation, we'll see why I need to have Docker on my machine. So with Spring Native, there are two ways to get started. One way is to get started using build packs, cloud native build packs specifically. And what those are is it's just another way to generate a Docker image. So I can choose to get started using build packs, or I can get started using the native image Maven plugin. Because I've chosen build packs and they will generate a Docker image, I need to have Docker installed. If I were to choose to use the native image Maven plugin, I wouldn't need to have Docker installed, but I would have some other system requirements and various things that I need to have installed on my machine. But if you're interested in that, you can come check it out and see how the native image Maven plugin works. So in this documentation here, it has information about the dependencies that I need to add. So rather than coming to the Spring Initializer, I could have also come here and checked out what I needed to add. It also has this system of toggling. You can see what you need to do if you have a Maven project, if you have a Gradle project, or if you have a Gradle Kotlin project, like in our case. And so if you're getting started with Spring Native, this reference documentation is a great place to start. And it has a lot more information than just the getting started with build pack section. Over here, it has an overview about talking about what Spring Native is. It talks about some key advantages, some drawbacks, and it also talks about the differences between a regular JVM and the native image platform. And these are what attribute to the longer build time and the faster startup time. So if you want to know why that is, you can read through this. As we said, we can get started using the build packs or the native image Maven plugin. Here, there's a list of various dependencies that are supported. There are a lot of Spring Boot starters here, as well as some Spring Cloud starters and other dependencies. If your application is using just these dependencies, then it most likely will work using Spring Native. And if it doesn't, you can create a bug in the Spring Native GitHub repository. So there's a couple more useful sections in here. The samples. So there are various samples in the GitHub repository. There are samples for security, data, cloud, Java, Kotlin, RSocket, reactive, serverless, all of these things that are supported, there are various samples for. So if you prefer to get started that way, maybe you start off with some samples and see how they fit into the Spring Boot application that you want to turn into a native image. Let's see how this is doing. Still running. So that gives me some time to talk about the native image options. So the native image wants to make the image that it creates as small as possible, which is why there are some things that aren't enabled by default. One of those interesting things is this enable all security services. This is a flag that you would need to pass to the native image command if you want to use Spring Security. Now, because of some pre-processing that Spring Native does, you actually don't need to add this manually, and Spring Native will add it for you whenever it detects Spring Security. There's also this flag, enable HTTP, which you will need to add if you want HTTP support. This is something that we'll need a little bit later. So I'll point out where it is now so you know where to find it later. All right, so this looks like it built our image. It's just installed locally here. Now let's see how to run it. Come back to my handy documentation here. And I'll take the command from there. And it needs to move this Zoom thing out of the way. It says that I'm going to use Docker to run this image that I created. And I'm just going to expose port 8080 because that's the one that my application is running on. And I should probably stop this application. And as we can see, it starts up very quickly, 126 milliseconds. I'm going to do this 3 times just for the sake of it, 114. And we can see that it continues to start up very quickly. So we got that instant startup time that we were hoping for. If we come here, I want to make sure that our business logic is still intact. So let's make some requests to our endpoints. First, we call the hello endpoint. We get back our 200 response and the body that we were expecting. Then when we call our talk info endpoint, we get back a 401 because this still requires a user to be authenticated. And then when we pass in the credentials, we get a 200 response from here as well and the response body that we were expecting. So everything is functioning the same as it was before. And we got this advantage of having this very quick startup time. Now, these advantages that come with creating native images, such as instant startup time, reduced memory consumption, and instant peak performance, are really well suited for a microservices architecture. So if you have a bunch of microservices and you want to try out Spring Native, you might want to start off with one of those microservices, turn that into a native image, and then have that still communicate with the rest of your regular Spring Java applications. And that's a situation that we're going to talk about now in the context of OAuth 2 specifically. So we're going to make this application into an OAuth 2 resource server, still keep it as a Kotlin application, and we're still going to turn it into a native image. And it's going to communicate with an authorization server that is a Java application, and it's not a native image. So let's see how we can do that. I am going to add the resource server dependency. I'm not going to take you back to the Spring initializer again this time, although that would be a valid thing to do. So I just have a little shortcut here. I'm going to add the Spring Boot starter OAuth 2 resource server. And then I can come here into my application configuration. And I no longer need this user detail service bean. I can get rid of this because the authorization server is now responsible for managing our users. So the resource server doesn't need to worry about that. The other thing that I want to change is instead of securing our application using HTTP basic, I'm going to say this is an OAuth 2 resource server. It is going to validate JWT bearer tokens that the client will send in. And the way it's going to validate these tokens is going to be defined by the authorization server that is running on port 9000 locally, specifically using JWKs to validate the incoming JWT bearer tokens. So this port 9000 is pointing to our authorization server, and the resource server needs to know where that's living in order to be able to validate the incoming tokens. Remember when I was talking about making HTTP requests earlier? This is where we're going to need to add that enable HTTP flag in order for the resource server to be able to make this call. So coming back to our build.gradle, if we come down here to the boot build image command, I can specify in here some options that I want to pass into the native image command, and specifically the enable HTTP option. So here I'm saying that I'm going to pass in some native image build arguments, specifically the enable HTTP argument. And if I forgot to add this, I would get an error message, and the error message would say something like, "You're using HTTP, did you mean to enable HTTP?" So a lot of the error messages that come from using Spring Native are actually quite useful. And it's not going to assume that this is what you want to do, but it'll give you a hint saying, perhaps this is what you were trying to do, and if so, this is how you do it when using native images. So that's pretty handy. All right, now that we have that ready, we should be able to build this resource server into a native image. So we'll run our same boot build image command. And since this is going to take a while, I'm going to come back to our security configuration here and talk about something that I didn't mention earlier. And that is why I'm using this host Docker internal. So this image, as we saw earlier, is going to be run inside of Docker. And from inside of Docker, if I say localhost 9000, it won't access localhost 9000 on my machine, which is where the authorization server is running. So one way to get around that is to use host Docker internal in place of localhost. Of course, this is just for local development, and I think it's only available on Docker for Mac and Docker for Windows. So we've been talking about the authorization server we're using. Let's see what that looks like. My authorization server is just another Spring Boot application. It's written in Java, and the way I'm able to make it into an authorization server is using the experimental Spring authorization server dependency. The 0.1 version was recently released earlier this year. And the way you add this dependency to your project is just like this. It's the Spring Security OAuth 2 authorization server. And as I mentioned, it is still experimental. Over here in our authorization server configuration, we've defined a client. Our client ID is messaging client. It has the secret, and it's using the grant type client credentials. Now, I'm not going to explain the OAuth 2 flow. I'm going to assume that you're familiar with authorization server and resource server and client. In the context of what we're talking about right now, our client is just going to be the command line that we've been using. So what's going to happen is I'm going to get a token from the authorization server. And with that token, I'm going to request a resource from our resource server, our Kotlin application here. And the resource that I'm going to request is the only protected resource, which is the talk info. In order to request that resource, I'm going to pass in the token that I got from the authorization server. And the resource server is going to validate it based on the way that the authorization server has told it to. So quickly, we'll look at how I'm getting that token. I just have a little script here. Bring that further up. And what this script is doing is it's calling the authorization server that's running on port 9000, and it's specifically calling the token endpoint in order to get a token. It needs to pass in the client credentials In this case, it's messaging client and secret. We saw that configured in the authorization server. And it's saying that the grant type that it's using is client credentials. From here, it's extracting the access token, and it's just storing it in an environment variable. So let's try running this. And I forgot to start the authorization server. Not a problem. I've done this many times before. It looks like it's going. We'll try it again. And let's make sure that we got ourselves a token here, and we did. So we can now use this token to call our resource server. I mentioned that the client that we're using now is just going to be this command line. But of course, you could use a Spring application as your client. You could write your application in Kotlin and then use the OAuth to client configuration to make the Spring Boot application into a client that's supported in the Kotlin DSL. In fact, anything you can do in the Java DSL is also supported in the Kotlin DSL. You can also turn the application into a native image. Spring Native does support OAuth 2 client, but just keep this simple. We just have a little script here. We're going to get the token, and we're going to do it all through the command line. Let's see how this is progressing. It looks like it's almost done. It's generated our image here. And we are ready to go. So we can run our image again using Docker. And I guess I'll do it 3 times. Make sure it starts up quickly every time. Looking good. So now we have our Kotlin application as a native application as a resource server. And let's see what that means. So coming back here, our client can request the hello endpoint still. Nothing's changed there. If I access the talk info endpoint, I still get back a 401. But this time, the way I am telling this Kotlin application, this resource server, that I am authenticated is by passing in the bearer token. So if I come here to the talk info endpoint, I can pass in an authorization header. And in this authorization server, I will provide, sorry, the Zoom thing's in the way again, a bearer token. Specifically the bearer token that we just got from the authorization server. So since I provided the token, the resource server is now responding with a 200 response and the body that we expected. All right, so that is all the functionality I wanted to add to this application. We took a regular Spring Boot Kotlin application without security. We added security to it using Spring Security. We turned it into a native image, and then we turned it into an OAuth 2 resource server that's a native image to show that it can still work within this larger ecosystem of many different applications. So coming back here, I'll say thank you very much for hanging out with us today. And I also have a list of resources that might come in useful to you. So this is the demo application that I just went through today. It has various commits for each stage of changes that we did. So if you want to go back to when we just added Spring Security before making it into a native image, you can just check out the appropriate commit from there. Actually, I think I haven't made this public yet, but if I haven't, I'll do this right after the talk. This is a link to the Spring Security reference documentation. This is a link to the announcement of Spring Native Beta. And then this is the Spring Authorization Server project on GitHub. So this is my last slide, and that's everything that I had.
Awesome, thank you. I definitely am learning a lot more about Kotlin since I have very minimal experience with it. So it's especially cool seeing that since a lot of the time it's been like Spring with Java versus Spring with Kotlin.
Yeah, it is nice how pretty much all the Spring projects in the Spring portfolio have full Kotlin support now.
Paul, do you have any commentary?
I don't. In chat, it's been a little bit quiet, but a few folks have kind of mentioned that they really need to get in and learn Kotlin, but it's just not something they're using at work yet. So it's kind of hard to find the time to dig into it. And then we briefly talked about the fact that both Mark and Josh seem to really enjoy doing Kotlin. And I know Mark for sure. Hang on, I've got some background noise.
City noise.
How do you like Kotlin versus Java?
For me personally, it doesn't really matter. It depends on, I mean, I think it's very much personal preference. I know some people prefer Kotlin because it's a little bit more concise. It has null safety, of course, but I'm not going to say that Kotlin is better and everyone should switch to using Kotlin, because it's not very practical if you have an organization full of Java developers that are fully comfortable in Java to now suddenly tell them that they need to learn Kotlin. I mean, some people may be interested in learning Kotlin. I know a lot of people are, but I think it's a matter of preference. I'm not going to choose one side or another.
Yeah, I was about to say before noise started up here, Mark will switch between the two. So like he's got a demo app he does with like using streaming, and sometimes he'll write it in Java, sometimes he'll write it in Kotlin. It's just interesting to watch how smoothly he switches between the two. Some more commentary in chat. Remelwek says, thanks for the presentation. Sweet Killin 9 just mentioned that he just got the Spring Security in Action book, and he's planning on digging deep into it. And our friend Spencer mentions that being officially supported in Android really helped boost Kotlin's visibility.
For sure, yeah.
Yeah. And then Sweet Killer as well just said, nice presentation, thanks.
Thank you.
Yeah, no, this was great. Like, it was something I could actually, like, without knowing it, like, kind of follow along, which is really nice.
Yeah, I actually find it's easier to follow along watching Kotlin than it is Java. And that's probably because of the conciseness. I still couldn't write either of them, but at least it's easier to follow along. I can kind of read the Kotlin easier as it's happening. Tiffany, that's your homework. I want you to do a Spring related live coding session.
Oh, that's terrifying. I have so much homework. Like I'm in school all over again.
You get a homework after every Tanzu Tuesday.
Yeah. Just think, Tiffany, you can teach Josh Kubernetes and he can teach you Spring.
We've discussed this.
Yeah.
Got to study for that CCAD.
There is that. All right, should we wrap this up?
Works for me.
All right, cool.
Sounds
Thank you
good.
so much, Ria, for being on. Tiffany, remind us who we've got next week.
We have Marcin, and I would butcher his last name so hard. There's a lot of Z's and X's, and I don't even know where to go. It looks very Polish.
I would go for Grisiak, but that's probably way off. Ria, do you know how to pronounce Marcin's last name?
I don't.
No. All right. Nobody does. We need Jakub. He'd be able to do it for us. We need to have like a soundboard of Jakub pronouncing his Polish co-workers' names. So we can just hit the button and have him say it. All right, well.
Yeah, and again, that's going to be deep dive into tracing metrics and correlated logs. And that's good if you just go to tanzu.tv/gt, that'll be on there.
Nice. Okay, cool. Yeah, Ria, thank you so much for being on. Tiffany,
Thank you
do
for
you want
having
to
me.
Thank you.
play us off or do whatever you do?
Yep.